Hey everyone, welcome. Today we're diving into something that sounds super simple, but is actually one of the universe's biggest, most unbreakable rules. We're talking about the impossibility of ever reaching absolute zero. Okay, just for a second, I want you to picture this. Imagine you could suck out every single last bit of heat from something. And I'm not just talking about making it cold, like freezing it. I mean getting rid of every tiny wiggle and jiggle of its atoms, bringing them to a state of perfect, absolute stillness. Sounds simple enough, right? I mean, you just keep making it colder and colder and colder. But here's the thing, physics throws up this huge, unmovable roadblock. So the big question, the one we're going to tackle today is, why? Why is this goal, which seems so straightforward, completely forbidden by the basic laws of reality? All right, so to really get why we can't hit this target, we first have to be super clear on what the target even is. What are we actually talking about when we say absolute zero? Temperature. It's not really about how hot or cold something feels on your skin. At its most basic level, it's just a measurement of motion. It's all about how much the atoms and molecules inside something are vibrating and jiggling around. So absolute zero, that's the theoretical point where all of that motion just stops. Completely. No vibration, total utter stillness. And the numbers here are just wild. So scientists use the Kelvin scale, where it's a nice, neat 0 Kelvin. But for the rest of us who think in Celsius, that's minus 273.15 degrees. That's a kind of cold that's almost impossible to even imagine. Okay, and this is where it gets tricky, where our normal intuition kind of leads us astray. Because you hear about this impossible limit, but then you hear about how ridiculously close we've gotten. I mean, we are so close that you'd think, come on, we've got to be able to reach the finish line. And I'm not talking about science fiction here. This is happening right now in real labs. Scientists can cool stuff down to just a few billionths of a single degree above absolute zero. We are literally standing on the doorstep of this ultimate cold, just peeking over the edge. And that's what's so mind-bending about it, isn't it? We've gone like 99.999, you get the idea, percent of the way. So what's the deal with that last tiny, tiny fraction of a degree? Why is that last little step so different? Why can't we just take it? Well, the first barrier we hit is an absolute monster. It comes straight from the rulebook of the universe, Thermodynamics, and I think of it as hitting an infinite energy wall. Okay, so here's the key thing you gotta get. Cooling something down isn't like just letting something be. It's an active job. You're not just getting rid of energy, you're moving it. To make something colder, you have to physically take the heat from it and dump that heat somewhere else. And this, right here, is where physics just slams the door in our face. The third law of thermodynamics lays it out plain and simple. The colder you get, the harder it is to grab that leftover heat. The law basically says that as you get closer and closer to absolute zero, the amount of energy it takes to pull out that last little speck of heat just skyrockets all the way to infinity. And this chart really nails it. Look at that. For each tiny little step down in temperature, the energy you need just goes whoosh through the roof. Taking that final step, that last little push to zero, it wouldn't just be difficult. It would take more energy than exists in the entire universe. Yeah, impossible. But okay, let's play a game. Let's say you're some kind of cosmic genius. You figure out a way around that whole infinite energy thing. You think you've won, right? Nope. The universe has another trick up its sleeve, and this one is even weirder. It has nothing to do with energy. It's about the very fabric of reality. This is what I call the quantum veto. You heard me. Even if you could solve an infinite energy problem, you still can't reach absolute zero. There's something deeper going on, something weirder, a fundamental rule that's just baked into how everything works. And to get this, you have to completely shift how you think about things. In our big everyday world, a ball can be perfectly still, right? Not moving at all. But when you zoom way, way down to the quantum level, all the rules get thrown out the window. In the quantum world, perfect stillness is a no-go. It's just not allowed. It's all because of this crazy idea called zero-point energy. It's the universe's background hum. It's the absolute rock bottom, minimum amount of energy a particle is allowed to have. And here's the kicker. That minimum amount isn't zero. It means that particles are always wiggling, always vibrating with a tiny bit of energy, even if you could cool them to 0 Kelvin. They literally are not allowed to stop. So, okay, if we can never actually cross that finish line, what happens when we get right up to the edge? What's it like in that neighborhood? Well, let's dive into the absolutely bizarre and wonderful things that start to happen in this super strange world near absolute zero. When you get things this cold, reality just starts to get weird. It does things that make no sense based on our everyday experience. It's completely wild. You get stuff like superconductivity, electricity flowing with zero resistance, superfluidity, liquids that flow forever without stopping. The very nature of atoms starts to blur, and they act less like tiny balls and more like giant spread out waves. And here's another way to look at all this weirdness. These aren't just cool physics experiments. You could almost see them as warning signs from nature. They're what happens when you get too close to a fundamental line in the sand, a boundary that the universe is telling you, nope, you're not allowed to cross this. So what's the big takeaway here? This whole thing isn't just some technical problem for scientists. The fact that we can't reach absolute zero tells us something really deep about the universe itself. You could even call it the law against perfection. I mean, think about it. Absolute zero isn't just about being cold. It's about perfect order. Everything perfectly still, perfectly known. But our universe, it just doesn't do perfect order. It's a universe that's all about change and messiness and things spreading out, what scientists call entropy. It's a universe that loves possibilities way more than it loves perfection. And that really leaves us with this one last kind of beautiful idea. The universe is capable of creating the most incredible, complex things, galaxies, stars, even us. But the one thing it just won't allow is perfection. There's always that tiny bit of motion, that little bit of uncertainty, that constant, tiny quantum jiggle at the heart of everything. And maybe, just maybe, it's in that fundamental imperfection, that constant hum of the universe, that all the real beauty and all the possibility truly exists.